Hi, we are Team Tekon 16277. I'm Shrenik,
My name's Nidir.
and we're going to be talking about ARM and attachment designs.
Our agenda is we're first going to start out with our introduction. We're then going to talk about light and heavy arms, then attachments, specifically claw, then a roller intake mechanism, separate scoring arms, handoff mechanisms, linkages, and then our summary.
So to start off with our introduction, ARMs and attachments are very vital for scoring in FTC, and to maximize your points within the time limit, which is 2 minutes and 30 seconds, your design must incorporate creativity, speed, and consistency, along with being very efficient.
Light and heavy arms. Light arms are usually arms that are attached to a servo that can perform small tasks. Some pros of them are that they are very useful for simple, low effort tasks. They're really fast, they're super easy to code, and they're also really lightweight. Some cons of them are that they have very limited weight support because they're on the servo, very minimal degrees of freedom, which means that they have low spaces where they can turn at, and they're also unable to perform complex tasks. Heavy arms, on the other hand, are arms that are usually powered by motors, but you can't directly power them because of the high weights. Instead, motors are connected to gear chains or belts that then rotate the arm. Some pros of them are that they can perform more difficult tasks, they can reach higher, they can also have multiple features on the same arm. But they're more difficult to code, they require a lot of torque, especially with heavier loads, and they require more parts to build.
All right, now we're going to talk about attachments, specifically the claw. So when considering how to build a claw, we have to start by first analyzing what are the requirements for building such a claw. For example, like what kind of element are you trying to grab in the game, and what kind of size the element is, and what kind of size the claw should be in relation to it, and also what you need to do to the element itself. How do you need to manipulate it, and much more. So in the example there, you can see the claw is perfectly matched to the scoring elements in the left corner. So starting with your claw design, the best methods that our team found was that to start with Onshape or any other CAD software like Fusion 360, which is a good platform for 3D printing. And 3D printing can help us create like a tailored claw and a very precisely manufactured to our game element, and that'll help us perform better in our games. So to start out with building your claw, you can start with a 3D printed claw, and this will help you make iterations faster. And 3D printed parts are better for allowing us to combine different sections of a claw together. For example, like joining a claw to its gears. And servo brackets that hold the claws can also be customized as well. And then after those are done, you can also make an aluminum version for out of CNC.
Roller intake mechanism. A brief summary, a roller intake mechanism is an active system that uses spinning wheels, usually rubber, on an axle to pull in an object when it makes contact. The robot can then control the object to its will. Some pros of it is that it can pick up from many different angles. It doesn't require as much precision for, say, a claw. And some cons of it is that it's very difficult to maneuver. It's also difficult to manage due to the high weight.
So separate scoring arms. So separate scoring arms are used to lessen the amount of work that's happening on your one main arm or your main scoring system. So, for example, like let's say you had an intake, you can have a separate scoring arm for a smaller task. So some pros of them is that they can perform tasks faster and they're more efficient, and they can be used for smaller tasks that don't need a large arm for. Some of the cons is that they can only perform the very simple tasks that you put them to perform, and they're also very difficult to build. They can also be difficult to manage in game.
Handoff mechanisms. A summary is that handoff mechanisms divide the action of picking up and then placing the object into two separate steps. One mechanism picks up the object, and then another mechanism takes it to perform the desired task. The main functionality of it is that it separates the object pickup and placement into two distinct steps. It involves two mechanisms, one for picking up and then one for handling the object afterward. The main pros are that it reduces weight in specific necessary parts of the robot and also simplifies certain actions. But some cons are it's very challenging to align the mechanisms, and coding the mechanism is also very complex.
So linkages. So linkages are used to convert rotational motion from a torque from a motor or a servo into linear motion. So some examples of linkages. So linkage slides. They're usually powered by a motor or a servo, and it's a two-bar linkage with multiple degrees of freedom with pushing in and out. And in the center of the link, there's a ball bearing or a linkage point, and they rotate on free axis axes to allow the slides to come in or to allow the arm to rotate. Next, a four-bar linkage. This is the type of linkage that keeps the end bar parallel to the ground at all times. They're used for parallel movement to a certain point. They can serve as a small extension, and they're mainly used for claws. Linkage isn't widely used because of the space requirements needed. For example, in the right corner, you can see the four-bar linkage. It has four axes of freedom. By powering one of these axes, you retain the parallel movement between each one.
So, a summary of what we just talked about: remember to embrace creativity when designing claws and arms. Remember to explore and test multiple design options and take advantage of the flexibility as part of FTC. It's better to do something creative than just copy something that somebody else did. And also focus on innovation and remember to think outside the box.